Good day, everyone, and once again we are back together. Thank you for joining us, your favorite uncle Mlungisi Nkosi, and we are still looking at. In fact, we're looking at chemistry this time around. Of course, this is to try and assist those who are busy with exams at the moment. So if you have not subscribed, please consider joining this family. And of course, just like and share at the end of the lesson, okay? And tell as many people that, hey, you've got a plug here. You've got your favorite uncle giving you good content on physical science as well as mathematics. And of course, if you want to get in touch with us, you can reach us on our email address. That's info@mlungisinkosi.co.za. All right, and please don't forget, we've got a super thanks feature wherein if you really want to, just donate any amount that you want to your uncle, please, you're more than welcome. Right at the bottom, you can just check their super thanks. Tell your parents, hey, you want to just thank your favorite uncle. Okay. All right. So let's get into the multiple choice section. This is from the 2022 May-June exam. Okay, the supplementary exam that was written recently. I hope that this will help in your preparation for the coming exams. All right, now let's look at it. So first of all, they say, first question, which one of the following compounds has the lowest melting point? Okay, so we are looking for the lowest melting point. So remember that melting point as well as boiling point are a function of intermolecular forces, the strength of intermolecular forces, right? So in this case, the lesser the strength, the lower the boiling point. Remember that they did say lowest in this case, so we do need to be aware of that. So in this case, it means that we'll look for the one that has the lowest strength in intermolecular forces. And I see we've got ethane there, which has two carbons. They're all alkanes. So they have London forces, right? So in this case, it means that the one that will have the strongest intermolecular force there would be B. So the option is B. Right. I'm just trying to get my pen to write there. There we go. All right. So the option there would be B. Okay, and then the next question, they say when CH2, so this would be ethene, right, is converted to CH3, which is ethane, the type of reaction is, now remember, to convert it from ethene to ethane, it means that we would have added, in this case, hydrogens, right? So you see there were two hydrogens in each, and now there's three. So it means we must have reacted it with hydrogen, isn't it? And of course, that type of reaction is called hydrogenation. Okay, so the next question says, which one of the following compounds in solution will change the color of bromothermal blue? So remember, what changes the color of indicators are either acids or bases. So in this case, the only one would be a carboxylic acid. In this case, and of course, the only one that is a carboxylic acid, that would be option B. All right, let's move on to the next set of questions. They say to us, we've got two different samples of pure calcium carbonate of equal masses, right? Please note that. So they are equal in mass, all right, but they are impure in nature, right? So they say they react with 0.1 mole per cubic decimeter of sulfuric acid. They say assume that the impurities do not react. Okay. Now, the graph below shows the volume of carbon dioxide produced for each reaction. So, in this case, I want you to just think about it. Obviously, the greater the mass of the pure calcium carbonate, the greater the volume of carbon dioxide that will be obtained, isn't it? So if I look at reaction 2, I'm just going to move that a little bit. So if I look at reaction 2, in this case, I see that I've got a greater volume of carbon dioxide. It means there's more content of calcium carbonate than there are impurities, right? in this case, there's more pure calcium carbonate for reaction 2. So they say to us, when compared to reaction 2, which one of the following statements best explains rather the curve obtained for reaction 1? Okay. Now, when we compare reaction 1 to reaction 2, you can see that reaction 1, it means that there were either more impurities, okay, or less calcium carbonate. You can put it in either one of that. So let's look at the options. They say the temperature, no, it has nothing to do with temperature or surface area. In C, they say the amount of impurities is greater in reaction 2. Remember, we are looking at reaction 1, right? They say the amount of impurities is greater in reaction 1. So the correct answer would be D. Reaction 1 has more impurities, and as a result, we received, or we were able to obtain less calcium or carbon dioxide for that matter. Right, so I hope that makes sense, right? So looking at 1.5, they say the equation below represents a hypothetical reaction. Okay, so we've got delta H there being negative 50, right? They say the activation energy for the reverse reaction is 110. Now, if you remember, I think for those of you who might have watched this, so in this case, when we've got a graph, or rather for delta H less than 0, meaning that delta H in this case, this is an exothermic reaction, right? It means we start with a higher amount of energy and we end up with a lesser amount, right? So what we know is that delta H represents the difference there between, so these would be our reactants. So this is the energy of the reactants here. Okay, so I'm going to say this is the energy of the reactants. So that's the reactants, and that's the energy of the products. Okay. Now, in this case, they told us that delta H, meaning the difference between these two, would be negative 50 kilojoules, right? And then they also told us that the activation energy for the reverse reaction. Now note, the activation energy would start, for the reverse reaction, would start at the products and end at what we call the activation complex. So it means that value there is 110, right? Okay, so, and the reason this value is negative is because you're taking a smaller value minus a higher value, so you get a negative answer for that. Now, I want you to note, they wanted to find out what is the activation energy, or in fact, which one of the following is the activation energy for the forward reaction. So we are looking at, now please, I want you to note, I wish I could have drawn this much better. So we are looking at the energy between this point here and that point. Okay, I'm sure most of you can see how that will be actually 110 minus that 50, right? And in this case, it will give us that energy there. So in this case, it means that we are going to get, so our activation energy, where is the correct answer there? So 110 minus 50, we are going to get 60 kilojoules. Okay, so that is the correct answer. Okay, now if you think about it again, if we've got that as 60, just for the forward reaction, it means that it's that small value over there. So yeah, in fact, if you don't understand this graph, please go and have a look at the lesson that we gave on rates of chemical reactions. In this case, we explain this quite concisely. All right, now let's move on to the next one. All right, now they say the reaction, sorry about that, the reaction, okay, I'm just trying to increase the, okay, so they say a reaction reaches equilibrium at 25 degrees in a flask according to the following balanced equation, okay? So there's our reaction there. So they say which one of the following will change the color of the mixture to pink, right? From pink rather to blue. So in this case, what we want is that whatever reaction occurs in that case should favor the forward reaction, okay? Should favor the forward reaction. Why do I say that? Because remember, once I favor the forward reaction, in this case, my reaction becomes less pink and becomes more blue in color. All right, so that's what we want, okay? So now the first one, they say to us adding water. Now, please, I want you to note, water, by the way, in this case is a liquid. Whenever you add a liquid or a solid, it does not affect the state of dynamic equilibrium, okay? It will not change anything. Right, and then the next one says cooling the flask. Now, I want you to note delta H is greater than 0, meaning this is an endothermic reaction. It means the forward reaction in this case is endothermic. So once I increase temperature, it always favors the endothermic reaction, right? But when so meaning that the reverse reaction would be exothermic. So in this case, I want you to please note, once we cool the flask, in this case, we will favor the reverse reaction because that's the exothermic reaction. And as a result, it would move more from blue to pink. It would become more pink. So that is not the correct option. So they say adding sodium hydroxide. Now, I want you to please note, if I add sodium hydroxide, in this case, which is a base, right? What it would tend to do is that it would take away the chloride ions in this case. I'm assuming those are from the acid. So as a result, what it will do is that we would actually end up favoring the reverse reaction. And so the only one that actually makes sense is if we added ammonium chloride. Why? Because remember, ammonium chloride has got NH4 ammonium ions and chloride ions. Now note, in this case, once we increase the amount of chloride ions, what does it do? It favors the forward reaction, and as a result, it means that my solution will favor the forward reaction, and I will actually get the solution to be more blue. So the correct answer there would be D. And if you do not understand what I have just said, please go and look at the lessons on Le Chatelier's principles, okay? The explanation of Le Chatelier's principles. Okay, right, next question. They say dilute nitric acid is added to distilled water at 25 degrees. Okay, how will this affect the hydronium ion concentration and the ionization constant of water at 25 degrees? Now, please remember that the ionization constant of water, it's called a constant for a reason. It does not change. It remains the same. So already that tells you that our options will be between C and D, right? But now if I add an acid, okay, if I add, they did say we are adding nitric acid, right? So what will it do? It will increase our hydronium ions concentration. So in this case, I'm looking for increase and remain the same, and that looks like option C. All right, moving right along. So we are now looking at 1.8. They say consider the ionization reaction 1 and 2. Okay, so we see there we are adding water. So in this case, we've got product X. Now, I want you to please note what happened. We started with H2O, but then it became H3O plus. What happened to H2O? It must have gained an H plus ion. So it means that obviously H2O gained an H plus and therefore became H3O. But where did it get that H plus rather? It got it from H2PO4 in this case. So what are we left with? This guy must be now HPO4 2 minus. Okay, why? Because it would have given away the hydrogen. Now we are left with only one hydrogen in this case. And remember, it was 1 minus, so now it would have to be 2 minus. And then for the second reaction, we started with something, and H2O again. H2O must have gained, okay? So we started with X, which is this guy over here, right? And again, it gave away an H plus. How do I know that? Because I had H2O becoming H3O plus again, right? So now when H2PO4 minus gives away an H plus, what does it become? It becomes, so we no longer have any H's in this case, hydronium ions, so it will become PO4, this time 3 minus. Okay, right, so let's look at those options. So X is HPO4 2 minus, okay, and Y is PO4 3 minus. And it looks like option A. So in this case, that would be the correct option. All right. I hope that makes sense, ladies and gents, that you are able to follow on in what I am doing. All right. Now let's go to the next question. Probably this will not be part of this exam at the moment. I'm not too sure, but I will inform you of that. I actually need to just check the scope of the exam, but nonetheless, either now or in future, you will need this. All right, so they say an electrochemical cell was set up using, okay, so in this case, that's there's the name just suddenly disappearing off my mind. Okay, and another half cell under standard conditions. All right. So now, yeah, man, what's this volatile substance? There's the name. It just suddenly, disappeared off my mind. Which one of the following half cells, when connected to that half cell, right, will result in the highest cell potential? Okay, so what you would have to do is you would have to look at your your standard reduction potentials table, right? So in this case, I'm going to take my my standard potential table and see. Okay, so if I take there's Hg, I'm still in my mind searching for the name of this guy. So there it is. So the potential of this guy is 0.85, positive 0.85, okay, volts. All right, and then if I take that with aluminium, okay, so aluminium is minus 1.66, so this is negative 1.66, okay. So if I take with zinc, zinc is negative 0.76. If I take that with cobalt, let's see, cobalt to cobalt 2 plus, that's negative 0.28. And with now, please, I want you to note here, don't think that it's platinum, it's actually hydrogen. And the reason why they put that platinum there so that it becomes an electrode, but the cell is actually made up of hydrogen. So remember that hydrogen is just 0.00. Okay, right. If I look at that, so it means that all of those have got the potential to become our anodes. So the one that will give us the highest potential should definitely be aluminium. Think about it. So in this case, you'd say that guy minus a negative of this guy. Okay. So once you add them up together, this will give you the greatest potential. I hope that makes sense, right? Okay, and then they say which the following reaction takes place in an electrochemical cell, right? So you've got copper chloride becoming copper plus chlorine in this case, and they say which one of the following is correct for this cell. Okay, they say it's a galvanic cell. Absolutely not. Remember, this would be an electrolytic cell. In fact, that's electrolysis, right? That's the process of electrolysis, where you are breaking down compounds and forming new ones, right, by using electrical current. Okay, a power source is needed. I absolutely agree with that. Okay, they say the reaction is spontaneous. That's not true. If we need an external power source, remember that's a non-spontaneous reaction. And they say copper acts as an oxidizing agent. Remember, if it acts as an oxidizing agent, it means that it is reduced, it gains electrons, but that's not true in this case. Now, I want you to note that we started on the left-hand side with copper 2 plus, because remember it's copper. When that guy breaks down, it becomes copper. Copper chloride is actually copper 2 plus 2Cl minus. Okay, so for this reaction to take place, it means that we took copper 2 plus, all right, and it gained electrons, and in this case it became copper. Now please note the misconception here is that copper acts as an oxidizing agent. That's not true. What is the oxidizing agent is the copper ion. It's the copper 2 plus ion. Okay, right, so that would not be correct. The only correct answer therefore would be B. All right, I just want to leave it there, ladies and gents. I hope that this has been helpful in you preparing towards your chemistry exam. All right, and of course, please don't forget to like, please don't forget to share, and please don't forget to just make a donation by saying super thanks to your uncle. And I'll see you guys next time. Shop, shop.